Alrighty. So, today, received some feedback on the previous classes. So we are going to continue kind of reviewing over the different topics, I guess. So essentially what's going to happen is I still receive concerns that although you guys kind of understood what was going on, you didn't know how to necessarily apply it yourself. And I perfectly understand that, and I know that it can be quite frustrating and everything. So my goal is to help you develop this problem-solving asset and be able to properly be able to use it effectively whenever you are trying to solve these kinds of problems, right? So there's a couple different steps that we've done in all the practice problems we have gone over, and how we can kind of effectively be able to use these problem-solving strategies. And I understand that it can be really tough to kind of effectively learn these, because it's not entirely intuitive at first, because although when you go ahead and you solve the problem, it's like, oh yeah, we're just kind of going ahead and solving this problem. It's hard to think of it in a coding sense. And what I'm trying to teach you is how similar this coding is in comparison to just kind of solving logic problems, solving these types of problems in general. Because many times when you go ahead and you solve these problems, they aren't actually going to be like super difficult problems that you can't solve yourself, right? And so that means that it shouldn't entirely be too hard to think of yourself, although I perfectly understand if it is really hard to understand. And I respect that, because I understand that this is not an easy topic to come about. And now when you go ahead and you actually solve this, it's important to develop a mindset in which you can effectively approach these problems and not feel intimidated by the fact that this is a programming problem. You can just kind of think of this as just another kind of problem that you would encounter, right? So a couple of pointers I guess I want to give are that these programming problems, programming in general, is meant to allow us to solve problems that we cannot normally solve. Now, what does this exactly mean, right? There's a lot of problems we can't solve. Problems that go beyond our human knowledge. We simply haven't discovered it, researched it. But there's also different problems that we cannot solve that involve heavy, intense calculations. Anything like essentially large calculations requiring many kind of loops of logic and stuff like that. That is what programming was created for, to help us solve these problems, because we cannot do it ourselves. So in order for us to be able to effectively program the program to solve these problems that we cannot solve, that means that we have to come from somewhere, right? A problem that we can solve. Because upon figuring out that problem that we can solve is when we can apply that same exact logic, except trying to program it so we can repeat it for more intense calculations. And it's something that it can be overwhelming at first, because many times when you look at these problems, you're thinking, well, how do I do this, right? But in reality, what you should be thinking is, what exactly is this problem looking for, and how can I simplify it, right? If a problem is asking you to to do a bunch of different calculations, then you can see, alright, well, all it's asking me to do is a bunch of these different calculations. I don't actually need to do them. I can just tell the computer to go ahead and do this for me, right? And if you recognize that, then you won't be bothered by the fact that there are these big numbers that they bring up into these problems, right? But if you kind of let it take over and go like, oh my god, these numbers are so big, there's absolutely no way I'm going to be able to solve this, then it's very, very hard to come up with an algorithm, right? But if someone were to explain it to you, it would make perfect sense because you kind of understand how the programming works on the back end of many of these different types of programming. So the things that you need to learn when solving these programming problems is A, to not get intimidated, and B, learn to hone your problem solving skills and be able to find kind of the most efficient path, the most efficient solution that you can possibly come up with. Because as efficient as a computer is, a computer also takes time, also takes kind of effort to do these calculations. And as a programmer, it is our job to minimize these calculations as much as possible, right? Because by minimizing it, we can solve harder problems faster. We can give it even harder problems to solve, right? So now we're going to go ahead. We're going to do just one problem this class, and I'm going to try to teach you how to simplify the problem in your mind, to think of it not as the problem that you see on face value, but as a problem that you can almost try and simplify into an easier problem that we would be able to solve even without a computer, right? So we can go ahead and open up CodingBat. So let's go over here. Right, so we're in CodingBat, and let's log in. So last week we went over a Logic 2 problem, right? So Logic 2 is the harder portion of logic, so it's not entirely easy to get. Makes sense. So we're gonna go ahead. We're gonna go to string 2. This one should be a little bit easier. Obviously not easy. So we have this short problem. The instructions aren't that long. We have 3 cases over here. I'll give you guys a couple minutes to think about this. The different steps I want you guys to do is 1, read and examine the problem. 2, simplify the problem so that you can solve it. 3, write out a pseudocode or a way you would personally solve the problem. 4, try and understand how you can turn the pseudocode into Python. So these are 4 steps. I know these steps are a little bit general, right? Hard to understand at first, but it shouldn't be something that is so hard that you physically couldn't do in the time period, essentially. So I want you to give it your best shot, and then I will go ahead and kind of make it a more kind of solidify your understanding. Alright, so hopefully you were able to go ahead and go through the instructions I put over there. Right, so now I'm going to go ahead and show you how I would approach it, right? So first step, we read and examine the problem. Return true if the given string contains an appearance of XYZ. So we have a string XYZ. This is something that we're going to be looking for, right? Where the XYZ is not directly preceded by a period. So XXYZ counts, but X.XYZ does not, right? So we can look at these cases over here. We can see preceded. What does that mean? Well, preceded means that it is followed, the XYZ comes after a period, right? So it'll kind of look like this inside the string. So we have these two cases, right? So if we were to go ahead and look at this, CodingBat actually does a great job of going ahead and simplifying this problem down for you. Now, what do I mean by this? What I mean is that it goes ahead and it kind of gives you a very short case. Cases that you are able to go through and look at and go like, yeah, that makes sense. Right, and it's important for this to happen because when we go ahead and we do these cases, it's easy for our logic to go ahead and examine this. So the first step that we do is we look for XYZ. So we look for XYZ. The next step we do is look if XYZ comes after a period, right? And if not, return true. If true, return false. And that's pretty much all that's going on over here. There's no fancy stuff going on. It's just these simple lines of code. So what exactly does this mean, right? We look for XYZ. We take this case over here. We look for XYZ. ABC, BCX, CXY, XYZ. Oh, it matches. That is great. Look if the XYZ comes after a period. So that would mean that the period comes right before the X. We look for it over here, and, well, doesn't look like there's a period before this X over here. What does this mean? If not, which is this condition right here, we go ahead and return true. So it works. Now, we come over here to the second case. We're given ABC period XYZ. So we look for XYZ, we go like, oh, we found XYZ right here. And we look if XYZ comes right after a period. And we see, oh, there is a period right here. So if not return true, well, it is true. So if true, right, we go ahead and return false. And we get a false over here. And we do the same thing for this case. I'm not going to go ahead and do it for you. I want you guys to run it through. And then I want you to perform step 4. Try and understand how you can turn this pseudocode into actual Python code. So I'll give you guys a couple of minutes to do that. I don't want to rush you guys, and I know if you are having a hard time trying to understand this, this can be a hard step to take because programming and just kind of going through the logic can seem like a very daunting task. So I'll give you guys a couple of minutes to do this. Alright, so hopefully you're able to kind of complete this, or at least attempt to transfer this over from these kind of 4 pseudocode lines into actual code. So we're going to do it as well. So we are given define xyz underscore there, and we get a string. Let me check what the name of this string is real quick. It is just named string. And so we define xyz there, and we get one input as string. So what we do is we check, alright, so this string, we're trying to look for xyz. Well, what is the length of xyz? It has 3 characters in it, right? So when we search through string, we want to make sure that we don't kind of overshoot, right? Because when we go ahead and we search for it, it's not like we can go ahead, we can just go like, oh, is like, essentially we have to loop through this, okay? And in order to loop through it, we have a for loop and we have a while loop. And these 2 loops are very similar to one another, right? So for loop is actually just a specialized while loop. And in this case, we can indeed use a for loop. So for I in range, string length of string, what does that give us? Well, if string is, say, length of our first case over here, we get ABC XYZ, we have 1, 2, 3, 4, 5, 6. So if we were to do this, it would go 0 through 5, right? And when it's 0 through 5, then that means it goes all the way up to the last character Z. However, if we're just searching for XYZ, the last character that can start this XYZ chain is actually the one 2 before Z. So we'll go ahead and we'll do length of string minus 2. So for I in range length of string minus 2, we want to see, alright, how do we check if this string that we're getting over here, that we're taking out and looping through, is equal to xyz? So we're going to do something called naming a temporary variable. So the temporary variable is almost always named temp. And the reason is because, well, it's temporary, right? So this temporary variable is used when you are going through loops. What do I mean by this? Well, when you go through loops, you tend to go through a lot of different cases. And in order to properly go through all these cases, we want the loop to be able to store these variables somewhere. So what we're going to go ahead and do is we're going to grab it from an index of I, and we're going to go all the way up to I plus 2. So what this does is, or I plus 3. Now why I plus 3 instead of just I plus 2? Well, if we were to go from I to I plus 2, then what would happen is it only goes and checks 2 characters. Because remember, when we're grabbing from an index from a string, it will block out that last index, in which case would be I plus 3. So temp is equal to string from I to I plus 3. So we need to check if temp is equal to xyz. So in the case that temp is equal to xyz, what would happen, right? We need to think, alright, well, we found an xyz. Now, what's so special about this xyz? Well, we need to look, is there a period before it? So, it's very simple. That means that the index would just be I minus 1 where the period would be. Now, we need to be careful, though. Because if I is index 0, meaning that it is in this first slot over here, if we were to grab index I minus 1, we would get an error. So we write an if statement if I is equal to 0 or string at index I minus 1 is equal to a period, then we can return false. And if this doesn't happen, then we can simply go ahead and return true. And it'll loop through this, and we can see that when we run this, we don't get all the cases right. And we're like, oh, something happened. What did we do wrong? We go ahead and we see, we have a bunch of none cases right here. What's happening? Well, in the case that it doesn't find an XYZ, it simply won't return anything because it doesn't get into this if statement. So we go ahead and after this for loop runs, we go ahead and we return false. And then we see, alright, well, it seems that we have a bunch of cases that are still wrong. How does this work? Right? When you think, alright, well, we run through these cases, we go xyz.abc. Go through this, we go through this, it finds xyz. I is equal to 0. And then we see, oh, this code isn't right, because it's actually the case if I is not equal to 0. Right? And this is actually an AND. Right? But then we go ahead and we see, alright, well, if I is not equal to 0, then what would happen, right? So we go ahead and we run this, we get a couple more cases right. That's pretty good, right? And then we see, alright, what is this case right here? abc.xyz, xyz. Well, it seems that there's an xyz that returns true over here, meaning that it should technically return true. However, this code over here will only return the first case, which it finds only right over here. So we go ahead and we store a return variable. And this return variable will essentially just tell us what we're going to return. So we're always going to be returning this return variable, right? Except over here, instead of returning something, we're simply going to edit the value of return var. So over here, if this is the case, then nothing happens, right? However, if this is not the case, right, we actually have to go ahead and write an else statement. Because if this if statement happens, nothing happens, right? And then we go ahead and we run this edit statement over here, then it'll go ahead and it'll return the wrong answer. So we're going to go ahead and we're going to type return var is equal to true. And then at the very end, whoops, we are going to be, whoa, did not know that was a key. Return var is equal to true. And then we go ahead and we see expected and indented block at line is equal to at line 7. So we go ahead and we do 1, 2, 3, 4, 5, 6, 7. And we go, oh, because this is an if statement here. And if this is an if statement over here, what does that mean? Well, that means that something has to happen within this if statement. So what we can go ahead and do is if I is equal to 0 or string I is not equal to the dot, then we can do return var is equal to true. So what happened over here is there's two ways we could have gone ahead and we could approach this if statement. The first way we can go ahead and approach this if statement is going ahead and trying to check each possible positive case or each possible case that could have happened. However, as we learned, there are two different ways we can do this. There's also the complementary way, or when we look at every single case that is not possible and cross them all out. And so we simply switch this around, and as we can see, we got all of the cases in the end right. So you guys can go ahead, look over this code. I hope this was able to kind of help you go over how you can program this type of problem and how you can kind of approach it without being kind of getting lost, right? Because the first step shouldn't always be trying to convert it into programming code, but how you would solve it if this was just given to you as a problem, not as a programming problem. So if anyone has any questions, feel free to ask them right now. If you do not have any questions, then thank you for watching, and we'll see you guys next week. Alright, it looks like no one has any questions. So thank you for watching, and we'll see you guys next week. Thank you.